Okay, good afternoon. So, as some of you might know, I've been playing with trying to develop a novel way of looking at the periodic table so that you can see the shells better. And so, I'm going to run through the elements, right? And this shows how that electron pairs, right? So, very simple. S1, S2, hydrogen, helium closes it off. Lithium, beryllium, right? So that's 2, S1 and S2, and they're paired off generally. Boron has one free electron. The free electron, paired electron, paired electrons, paired electrons. Carbon, because there will be 3 here eventually, like it works in 3, right? 1, 3, 5, and then pairs of those is the way it seems to work. So what carbon tends to do is instead it borrows these electrons and gives itself 4 bonds, but really not always. Lithium, beryllium, isn't that right? Boron, carbon, nitrogen, 3 electrons, none paired. Oxygen pairs up one of the sets of electrons. Fluorine pairs up 2. There's 1 freaking electron left. So very strong, going to be a strong electronegativity because look at all of the pairiness and 1 unpairedness on that. And then we close it off with neon. So this is S1, S2, SP. P. Okay, where are we? Sodium, 1 free electron. Magnesium closes off that pair. Aluminum, silicon, phosphorus. See, but it's nice that it sort of like gives you this overview of the way they stack up, I think. And for compartmentalization, there's S's, there's S's, there's S's. P's is going to be turned into a full P in a little bit. And then I think we've got the D's too. Okay, where are we? We are at phosphorus. Sulfur, close it off. We got a pair there. Then phosphorus, sulfur. Oh, chlorine, right. Chlorine, once again, only 1 space, so going to be a very strong pull on that. And then we close it off with argon. See, in this way you can really look at, this way you can do a hybridization with carbon and show how those bonds open up, because each of these basically really represents an electron, and we're just piling on the electrons, right? So where we are, argon. Okay, now we're going to move over here. So what happens next is actually, I'm just going to rush these down. I have enough to do all the elements, but I'm only went up to 30 so far. There we go. So what happens is you get, what's that, potassium, calcium first, because the S always wants to be satisfied first. And then we go to scantium, titanium, vanadium. Chromium does a weird hybridization where it steals one of these electrons and pulls it down so that it can have a simple 5 unpaired electrons, but then it donates it back, and then we get iron, manganese, then iron, manganese has got that next hybrid, iron, cobalt, nickel, copper. Once again, because it's almost so satisfied, let's take that zinc away because it's not there yet, we're only at copper. Because this is so almost satisfied, what it does is it borrows one of the electrons from here, pulls it down, so this is closed off, but we have a loose S, and then finally zinc closes off that stack of the 30. So this is going to be the, what's this? This is 4S. These are the 3Ds. These are the, 3Ps? 3 S's. S, P, S, P, D, S, and would be PDF and all of that. But anyways, so this would stack on here, right? Because the S's all stack on top of each other. This would stack on there, because this is brought in. And notice how when you do the pairs, that this turns into such a nice, where it's like 2, and the 3, then the 5, then the 7. It's like 1, 3, 5, 7, only pairs of them, because electrons only have half spin, they're only around half the time, so they need another electron in that same orbit to really fill it out. Anyways, so thoughts?